I was dogmatic at one point. Not anymore. Okay, so let's talk about populations, samples, and machine learning. What, did this class just get fun? I thought so.
If the assignment was done, then yeah, it's not fun.
So, an experiment's population is a complete collection of objects that we would like to study. These objects can be people, machines, processes, or anything else we would like to understand experimentally. Of course, we typically can't measure all of the population. Instead, we take a subset of the population called a sample and infer the characteristics of the entire population from this sample. However, this inference that the sample is somehow representative of the population assumes the sample size is sufficiently large and that the sampling is random. So you don't want to have a means of selection of the sample that overrepresents or underrepresents some group in it systematically. Otherwise, you don't have a very good sample of the population. You have a sample of maybe like some group of the population, but you don't have the full population sampled. Good. So now is the part where you're like, okay, boring, statistics, and then, oh wait, machine learning is a field that makes extensive use of measurements and statistical inference. In it, an algorithm is trained by exposure to sample data, which is called a training set. The variables measured are called features. Typically, a predictive model is developed that can be used to extrapolate from the data to a new situation. The methods of statistical analysis we introduce in this chapter are the foundation of most machine learning methods. So although it is a little dry, like talking about probability and statistics and rolling die and that kind of stuff, there are some really cool applications of these statistical ideas, and I think that they're fun. So I want to talk about this in the example. So consider a robot. I had a lot of fun with this example. Pierre, with a particular gravitas and sense of style. He seeks just the right-looking pair of combat boots for wearing in the autumn rains. Pierre is to purchase the boots online via image recognition and decides to gather data by visiting a hipster hangout one evening to train his style. For contrast, he also watches footage of a white nationalist rally, focusing special attention on the boots of wearers of khakis and polos. Comment on Pierre's methods.
No.
I couldn't help but take a little jab. Okay, so features in the boots are what Pierre is looking for, right? So features are the variables that are measured. So they might be like the heel height, or maybe the stitching, or the height of the boot.
Like
Material of the boot, color. Those sorts of things would be variables that Pierre would be trying to measure and keeping track of. And so his training algorithm needs to know which features, so it needs a list of features that he's taking data points of, right? And choosing two places to sample certainly enhances the sample or training set. Positive correlations can be sought with the first group of desirable samples. And then the negative, a negative correlation, we'll talk more about correlation, but a negative correlation would be sought for the second group. So like, it might be like, okay, this group's got like really high boots, but the other group's got low boots, and so one of these is preferable to the other in terms of style, so I'm going to go with the one that I know is supposed to be better. And so he went to the hipster hangout thinking the hipster is fashionable. The hipster boots are supposed to be the cool ones. The white nationalists with their polo and khakis and tiki torches, clearly not fashionable, and so their boots are considered to be not fashionable and undesirable. So he's trying to get correlated with the one group and anti-correlated with the other. And when you have this, when you have sort of like an outcome that's known, so when he goes to the hipster hangout, he knows that like, these boots are supposed to be like trendy, right? So the trendy boots, it's called supervised learning when it knows the outcome of the training set, what is to be found in there. Like, he knows when he looks at the hipster boots, these are supposed to be stylish. When he goes and looks at the khaki polo group, he knows those boots are supposed to be not stylish. So it's called supervised learning when he knows the outcome of the training set, and it helps to train. There's also unsupervised learning, which is another topic. Yeah, so that's how. I mean, it's kind of like a futuristic, kind of silly example of a robot picking out shoes, but this sort of machine learning is exactly the type of thing that we use to try to make machines intelligent, and a lot of it comes down to statistical inference. Okay, so these statistical methods that we're going to learn, although we are mostly looking at them from the perspective of, oh, we need to measure some quantity, because this is instrumentation and measurement class. What you do with that, and in the analysis of the data, is like there are some really cool applications. It's not just like measuring something like, oh, cool, the weight of that is 5 kilograms. You also might be able to decide to throw the weight or not. At a white nationalist. I'm not saying you should. I'm saying there are worse things you could do with it.
Better things.
Also better things. I don't want to encourage violence. We don't want to encourage the robots to be violent either, generally speaking. All right, I gotta